All right, hey everybody. So now we're going to do solving quadratic functions by completing the square. And we have done factoring, we've done taking the square root, we've done quadratic formula, and now we're going to do completing the square. Quadratic formula and completing the square both have several steps. Completing the square, is by hands down longest, has the most steps. But it always works. The taking the yeah, I just want to say that. Save that comment for another video. All right, so the purpose of completing the square is to make a perfect square trinomial. And when we make that perfect square trinomial, a perfect square trinomial is a trinomial that can be written with two terms and then a square. Two terms and then a square. And so the purpose of that is it's called completing the square because if we use what's called these algebra tiles, you're making this square thing. You're completing the square portion. You're making visually a square, or you're making the square component. Completing the square has a ton of steps. Quadratic formula has several steps, but they always work. Factoring doesn't always work, even though it's quote unquote the easiest. All right, so if we use these are called algebra tiles. If we used them, then you visually see that you're completing a square. You're making a square, or you can think of it as I'm making it possible so that there's a square component. And then it's x plus or minus something right here, and then some number right there. And so you're making it possible to complete that square component. All right, so right now, all I want us to do is figure out what goes here so that we can write the perfect square component. All right, and the way we're going to do that is we just use this formula, b over 2. And remember, b is the number touching x. So we're going to do 16 over 2. We get 8. Right? And it's called completing the square. So we're going to square it. So we get 64. So 64 is going to go right there. Then this, b over 2, that piece, goes right there. Here's y. So just hang on. So we're going to write x plus 8 squared. So if we take this x plus 8, I want to show you. X times x is x squared. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. 8x times 8x is, should be next, is 16x. 64, x squared. So it all comes out. All right, so the constant we would add is 64, and the way we got that was we did b over 2, and we squared it because it's called completing the square. All right, then we needed to factor it. So to get this guy, he's just b over 2. You can take this middle term and do b over 2. There's another way you can think about it, and I'm going to come back to that pattern in just a minute. All right, let's do it again. B over 2, then we complete the square. So the number touching is -1 over 2 squared. -1 times -1 is +1. 2 times 2 is 4. So 1/4 needs to go here. And so the letter T, and then right there is here. So we have -1/2. Right, I want us to see, okay, good. I want us to look at a couple other patterns in this, okay? Notice this b/2 goes right here, b/2. Notice the b/2 squared goes there. Notice, whoops. Notice this sign, this negative, is the same right here. And notice if you took 1/4 and you took the square root, square root of 1 is 1, square root of 4 is 2. So you happen to get that as well. All right, let's come over here and let's look at those same patterns. So b/2, b/2, b/2. We took our last term and we took the square root, and the reason I took the square root is because it's the opposite of squared, and the square root of 64 is 8. Also notice plus sign, plus sign. It's a plus sign because there's nothing right there. All right, so notice those kind of patterns as we're doing this. Whew, these are the steps. All right, for our course, all right, I'm only going to give you ones where the number in front right here is a 1. There's no number there, like a 2 or a 7 or something, or a 3 or a -1 or whatever. Okay, so you need to get the x squared and the x by itself. And so what I normally have you do is I have you write the squared term and the linear term by itself, put a blank, move the other guy over, and put a blank. And so in that blank goes that b/2 squared. And then we go through this process, okay? So you may want to pause the video, take the step, write down the steps. So a must be 1. You're going to isolate, and what I normally do is that I write plus blank on both sides. Then we do b/2 squared. Then we write the factor, and then we do the square root property. And don't forget plus minus. All right, let's do some problems. It's not as scary as it looks. All right, this already has the squared term and the linear term by itself. So we're going to do z squared minus 2z plus blank equals 24 plus blank. In that blank, we're going to do b/2 squared. So b is this -2. And I have that 2. And then it's squared. So -2/2 is -1. Squared is 1. So I'm going to put 1 here in that spot. All right, now I need to write this guy. I'm going to write a z. And then what goes right here is this guy, just the b/2. So we're going to write -1. And then 24 plus 1 is 25. So I've rewritten this z squared minus 2z plus 1 as a perfect square binomial. So z minus 1 squared. And I need to now take the square root on both sides. So when I take the square root on both sides, I get z minus 1 equals plus minus, because when you take the square root, you always do plus minus 5. And so I have z minus 1 equals -5. Z minus 1 equals +5. All right, when I do this, I need to add 1 to both sides. And and I get z equals -4. I need to add 1 to both sides. I get z equals 6. And those are my two answers. I'm going to get two answers 99% of the time. And let's do another one. Alright, so x squared minus 4x plus blank. I need to move him over. When I move him over, he becomes negative plus blank. In that blank, I'm going to do b over 2 squared. So b is -4 over 2 squared. -4 over 2 is -2. Still need to square it. So -2 times -2 is +4. So in that blank, I'm going to write +4. Alright, so now I'm going to write this guy as a perfect square. So I'm going to do x, and in this spot right here is that b over 2. And so b over 2 is -2. And then -2 plus 4 is +2. This is right here. Alright, now we have a square. When you take the square root, and so we get x minus 2 equals plus or minus the square root of 2. Square root of 2 is not a perfect square, so we're just going to leave him alone. And so we need to add this 2 to both sides. This 2 is just a regular number. That 2 is in jail. He's under the radical. When you take the square root of 2 in your calculator, you get 1 point something. It's not actually 2. And so our final answer is x equals 2 plus or minus, so this 2 is that 2, plus or minus the square root of 2. And so 2 plus the square root of 2 is some number, 3 point something I think, and then 2 minus the square root of 2 is some number, is negative point like 6 or something. All right, let's try this guy. So x squared plus 4x plus blank equals, we're going to move that over. When we move him over, it becomes positive plus blank. That blank is going to be b over 2 squared. B is the value touching x, so 4 over 2. 2 squared is 4, so I'm going to write 4 in this spot. Alright, so now I'm going to write it as a perfect square. So x, 6 plus 4 is 10. Right here is that b over 2. So I'm going to write the number 2, positive 2. And so I have x plus 2 squared equals 10. I need to take the square root to get rid of that squared. When I do that, I get x plus 2 equals plus minus square root 10. 10, there's no perfect square. You can't take out a 4, you can't take out of a 9. So we need to subtract 2 on both sides. And we get x equals -2, right there, plus minus square root 10. Sorry, it's kind of, square root 10 is like 2 point something. Alright, so I want to pause on that. And then the next video I'll do a couple more problems.